What happens behind the scenes when Python adds small ints? I was fiddling around with ID recently and realized that, see? Python does something quite sensible. It ensures that small ints always have the same ID. But then it occurred to me to wonder whether the same is true for the results of mathematical operations. Turns out it is. Seems like it starts failing at n equals 257. But sometimes it still works even with larger numbers. What's going on here? How does Python do this?
Python keeps a pool of int objects in certain numbers. When you create one in that range, you actually get a reference to the pre-existing one. I suspect this is for optimization reasons. For numbers outside the range of that pool, you appear to get back a new object whenever you try to make one. Source. PyObject pyint underscore from long while ival, return value, new reference. Create a new integer object with a value of ival. The current implementation keeps an array of integer objects for all integers between -5 and 256. When you create an int in that range, you actually just get back a reference to the existing object. So it should be possible to change the value of 1. I suspect the behavior of Python in this case is undefined. Smile. Emphasis mine.
You've fallen into a not uncommon trap. The two expressions, 2x plus y, and 300 plus x, don't have overlapping lifetimes. That means that Python can calculate the left-hand side, take its ID, and then free the integer before it calculates the right-hand side. When Python frees an integer, it puts it on a list of freed integers and then reuses it for a different integer the next time it needs one. So your IDs match even when the result of the calculations are very different.
As far as I know, it has nothing to do with the size of the parameter. It must return a lifetime unique identifier, and it can return the same result for two different parameters, if they do not exist concurrently.
If you want to say more, please consider subscribing.